Hello everyone. In this video I'll be talking about one of the most important concepts in computer science, which is recursion. So let's get started. Let me first create a module with the name of recursion. Wait a second. So it's fine. Yeah. So the basic question you might have is what actually is recursion? So let me explain this to you in simple terms. Recursion is it's related to functions. It's a basic practice that we can call any function from anywhere within our code. And but in recursion, what happens is the function is called from within its own body. So that's the basic feel about it. And you may ask how is it useful? How is this principle useful? This principle of recursion. So the thing is, if a problem has an iterative solution, you can solve it using loops, then you can solve it using recursion as well. If you can solve it using loops, you can solve it using recursion as well. So here it gives you a variety of options. You have choice what kind of thing you want to do with the problem, how you want to approach a problem. When you have multiple approaches, the solution of a problem, to find the solution of a problem becomes much easier. So that's the basic principle behind recursion. So let's just talk about functions for now. Let me create a class by the name of print. No. Okay, so wait a second. So I don't know what happened. Let me just delete it and make it once again. Okay, so I can say let me just start with a main function first. Okay, so the question could be something like this: print first 5, let's say, natural numbers. Okay, let's be a bit more specific. Without using multiple printable statements within the same function. Okay, so the first thing we can do is we can use a loop to do this. Let's just say we call this function print static. The return type is going to be void, as we are not going to return anything. We're just printing the numbers. Static void, and let's just say print. And I can say I can use a for loop for int I is equal to 0. We have to start from 1, right? I is less than, let's say, 6 I plus plus. So I can just say as out I, and I call this function from my main function print. Let's run this. So recursion is a bit complicated. It's not like complicated. Like the concept is new. It's like there's like a lot of abstraction in this concept. A lot of things are happening like behind closed doors sort of thing. So as you can see, this function has successfully printed first 5 natural numbers. So let's see first like how the function calls work. Let me like approach this problem with a different point of view. So the thing I can do is I can do static void print1. I'll just say s out and print1, and from within this I will call the print2 function, which we haven't obviously created yet, but I will so I can say s out just 2, and from here it will call the print3 function. Print3. Okay. Let me just make a print3 function. It will just print the number 3. And it will call the print4 function. Okay. So let me just make the function print4. I can say system out, and it will print the number 4. It's fine. And from here I will call the print5 function. So s out. Okay, I have to create this function first. Static void print5. So okay, I will say system.out print5. Okay, it's not going to call any other function now. Let me call this print1 function. Let's see what the output will be. It's taking some time. Okay, so like it has printed successfully the first 5 natural numbers as expected. Let me put like a debug pointer here. Let's debug this. Okay, so we are calling our print1 function from main function. Okay, got into our print1 function, and like we are using the println method. It's going to print1. Okay, then moving on to the like we are now calling the print2 function. It's going to print2. Now we are going to like call print3 function. It's going to print3. Going to call print4 function, printing 4, calling print5 function, and printing 5. Now see what happens here. Like when this function ends, like print5, see where it like goes back. This is our stack. Okay, so this function has been successfully executed, so the pointer will go back from where it was called. See, it was called from like print4, so it will go back to here. So like print5 has been released from the stack now, and now it's print4's turn to be released. It will go back from where it was called. print 4 has been released, as you can see here in the stack. It's now a print 3 function. To go back from where it was called from print 2, and the print 3 has been released from the stack. Print 2 was called from print 1, and it will be released from the stack. And print 1 was called from main, and print 1 will be released, and then main will be released, and our program has executed successfully. And this is our output 1 2 3 4 5. Okay, so as you can see, I gave you a rough idea about how function calls work in Java and what's the stack doing. It's the function call, call where you have made call. I made this call print 4 from print 3. Once the print 4 function has been successfully executed and there is no other function down the stack other than print 4, if this is the case, then print 4, if it has been successfully executed, the stack pointer will go back to from where it was called. I hope it's clear. It's a bit complicated. I'm not able to describe it in words successfully, but I'm trying my best. So yeah, it's print 2 function was called from here. When the print 2 function had successfully executed, it will go back to this, release the print 2 function from stack, then see where the print 1 function was called from. It was called from main, release the print 1 function from stack, go back to main, and release the main now. That's pretty much the idea behind stack. Okay, so let's just see now how can we approach this problem recursively. Okay, I'm not going to use any loop for this. So I'll just say static void print. How many numbers do I have to print? I have to print 5 numbers, right? Let's take an argument int n. In the beginning it's going to be 0 or 1. It's going to be 1. As we are printing from 1 to 5, we are printing whole numbers. So let me say first s out n. Okay, in the first run of this function it's going to print 1, as we are going to pass the argument n as 1. So it's going to print 1. No problems over there. Then what I'm going to do is I'm going to call this function print within its body, and what I'm going to do is I'm going to change the value of this n. I'm going to change it to n plus 1. If in the beginning n was equal to 1, now for this particular function call it would be n is equal to 2. So it will then come here and print 2, print 3, print 4, print 5. This will keep on going. If it never stops, our stack is going to fill up with various function calls and stuff. Various functions are going to be stacked in our stack memory, and as it is a type of memory, there would be a time when it runs out of space. That's what we call in stack overflow error. Let me just show you what this stack overflow error is. Let me just run this. I'll just say print from 1. Okay. See, it's going to print forever and ever before it hits this error. It's a long list. It's basically a stack overflow error. My stack memory was able to hold these many function calls, 19,074 function calls or 76 function calls, and after that there was no space left in the stack, and that's why like it overflowed. So like how can we like stop this from happening? How can we make this function stop after like first 5 numbers have been like printed in our case? Like that's the requirement of our problem. We have to find a solution for that. So what we are going to do is we are going to use something called a base condition. Okay, so this base condition is like pretty important in terms of recursion, as if we don't provide a base like condition to a function, it's going to like call on to itself like endlessly till our like stack overflows, stack memory, like till our stack memory is like completely filled up. So we have to put a base condition here. So what's a base condition? I can say like if n is equal to 5, just print 5, and then I'm going to return from here. Okay, let's see what happens in this case. It's going to print till 5. Let me put a like a debug point over here so we can see what's actually happening. Okay, so we are calling the print function. We are passing in the argument as 1. So it's going to check this like against our base condition. It's going to ask like if is n equal to 5. It's going to be like no, n is equal to 1. Okay, move on. It's going to print 1. Okay, then it's going to call print n plus 1. Initially our n was 1, now it's going to be 1 plus 1, which is equal to 2. So as you can see, n is equal to 2. It's again going to check if n is like equal to 5. It's going to like no, it's not, it's equal to 2. So it will ignore all of this block and it will print 2. Then it will be like print 2 plus 1, 3. It's once again going to check like is n equal to 5. It's going to be like no, it's not, ignore this block, print 3. 3 plus 1, 4, print 4. No, it's not equal to 5, print 4. Now n is equal to 5. It's going to be like yes, n is equal to 5. So just print 5 and return from here. Done. So that's basically how we like, this was like a very basic recursive program. I hope you got the feeling of like what recursion is, like you got a basic understanding of what recursion is. There's another like problem which we can solve using recursion. It's a Fibonacci problem. So it goes on something like this. Don't want this to get up. So it goes something like this. Find the nth Fibonacci number. Okay, we actually have a mathematical formula for this. F of let me put it in comments. F of n is equal to f of n minus 1 and plus f of n minus 2. Okay, so this is our mathematical formula. If you would like to like find the nth Fibonacci number, what you have to do is you have to find the Fibonacci number n-1 and then add it with Fibonacci number n-2. So this is like the formula for it. So like how can we approach this problem recursively? Okay, so let me just create a function, static int, and let me call it f, and I have to like find the nth Fibonacci number, so I will just name it n. Okay, so what could be our base condition here? I have like made a recursive diagram just for this, so let's check that first. It's going to take some time to load. My internet connection here isn't that good. Okay, so I guess it's somewhere over here. Okay, so like if you want to like find the Fibonacci number, but like the third Fibonacci number, it's going to be like the recursive tree is going to something. Let me just write the code first and then I'll explain it to you. It's not going to make much sense as of now. So what's going to be our base condition? We know that, let me just write it here. We know that fib of 1 is equal to 1 and fib of 0 is equal to 0. So what it means is the first Fibonacci number is 1 and the 0th Fibonacci number is 0. Okay, so maybe we can do something with this information. What do we have to like? We have this formula f of n is equal to f of n-1 plus f of n-2. Okay, so what I can do over here is I can just say f of n-1 and add it with f of n-2. Okay, it's like going to make two function calls. First this one is going to execute. After this one has been finished executing, then it will move on to this part. Then it will start like executing this part of the problem, like this part of the function. So I hope it's clear. So the problem is almost 90% done, but we have tried the base condition over here. What could be our base condition? I've already wrote it down over here. Fib of 1 is equal to 1 and fib at 0th place is equal to 0. So I can say if n is equal to 0 or n is equal to 1, just return n. Hope it makes sense. If it's not, I will show you this diagram and after that it's going to make complete sense to you. So let me just say, let's just first see like what are Fibonacci numbers. So these are numbers like let me show this, show it like this. The first whole number is 0, the second is 1. Okay, so the third Fibonacci number will be 0 plus 1, it's going to be 1. The fourth will be like 1 plus 1, it's going to be 2. And similarly this one is going to be 2 plus 1, which is equal to 3. Then this one is going to be 3 plus 2, equals to 5. This one is going to be equal to 8. This one is going to be equal to 13. And this one is going to be like equal to 21, and so on. So these are basically Fibonacci numbers. What I am doing here is to find this 21, I had to like add these two previous Fibonacci numbers. Hence the formula which I like got here. Fibonacci of Fibonacci number at nth place is equal to Fibonacci number at n minus 1 plus Fibonacci number at n minus 2. That's what I'm doing. So I hope it makes sense. Let's look at our diagram first. So here I'm going to find like f of 3, like Fibonacci number at third place. So it is going to be equal to f of 2 plus like f of 1. Okay, it's like going to be making two separate function calls. This f of 3, like take it as like I have passed in like the argument 3, and down here I'm going to make two function calls, as you can see, f of n minus 1 and f of n minus 2. That's like pretty much seeing what I'm doing over here in this recursive tree. It's going to be f of n minus 1, which is f of 2, and this is going to be f of 3, f of n minus 2, which is f of 1. Okay, so to further break down this problem, it's going to be like f of 2 is n equal to 1. It's going to be like, no it's not, it's 2 currently. Okay, so it's going to break it down into two other problems, like two other function calls, f of n minus 1 and f of n minus 2. Here f of n minus 1 is going to be like f of 1, and f of n minus 2 is going to be like f of 0. So we know that Fibonacci number at first place is going to be equal to 1. That's like pretty much clear. So we have like typed in here, see, we use the return like statement here. So it's going to return whatever value it's getting from here and pass it down as like I told you, like I taught you like in this print class. Here whenever like it was not this recursive one, like I created 5 function calls, 5 functions, and each function was calling the next function from within its body, that one. So as you saw, when the function was completed, like when the execution of function was completed, it was returning from where it was called, like print 4 was returning back to print 3, then print 3 was returning back to print 2, print 2 was returning back to print 1, and so on. Same is the case here. This like function call f of n minus 1, it's going to return whatever value it gets to its previous function call. I hope it makes sense. See, let me make it pretty clear. This is the first function call. This is our formula, f of n minus 1 plus f of n minus 2. Okay, it's going to first execute the left side of the problem. It's going to execute this first, left hand side. So it's going to call f of n minus 1, which is like f of 2 in this case, n minus 1 equal to 2. Okay, so now to break this further down, it's going to like check against our base condition, which is here. If n is equal to 0 or n is equal to 1, just return n. It's going to be like, is n equal to 0 and n equal to 1? It's going to be like, no it's not, it's true. So it's going to like ignore this block of code completely. That's like this return n statement, it's going to like ignore it completely, and like it's going to come down here, and like it's going to start executing the left hand side first. Okay, it's going to start executing this side first. So it will be like f of 1. Okay, so now our n is equal to 1. It will once again check, is like n equal to 1 or n equal to 0. It will be like, yes it is, n is equal to 1. So it's going to return n. What is it? N is 1. Okay, so it is going to return like, this is also plus, it's going to return like 1. It's going to return 1 back to it. Okay, so now the flow of the program, see, the flow of the program went something like this. It executed the left half first, f of 2. Now f of 2 is further made up using two like Fibonacci numbers, f of 1 and f of 0. It's going to execute f of 1 first here. Then f of 1, as we know, we have put in our base condition that if n is equal to 1, just return n. It's just going to return 1 back to here. Now it's going to execute right half f of 0. So it's going to check is n equal to 0. It's going to be like yes it is. Then in this case it's just going to like return 0. Okay, so it's returning 0. Now it's going to add 1 plus 0. It's going to equal to 1. F of 2, from where it was called? It was called from this function called. It's going to return whatever the answer was. The answer was 1 plus 0 equal to 1. So it's just going to return 1. Now it's going to execute this half of the problem. F of 1, it's going to once again check is like n equal to 1 or n equal to 0. It's going to be like yes it is, n is equal to 1. It's just going to return like 1 in this case as well. It's 1, going to return this as well. Now it's going to add 1 plus 1. The 1 it got from this side and the 1 it got from this side. It's going to execute this 1 plus 1, which is equal to 2. I'm trying to like write with the mouse, so spare me for this diabolical handwriting. So it's going to like 2. Okay, then it's just going to like return it. Simple. I just like did a whole dry run of like this recursive algorithm over here. Let's just see it in action. So I will just say I'll just like create a variable and name it nth equaled f, and I'm going to find like the Fibonacci number at third place, like the third Fibonacci number. In our dry run it was coming out to be 2, as we like calculated over here. This was coming out to be 2. Let's see. So sorry, I forgot to like print this. 10th. Yeah, it's equal to 2. Let me put like a debug point over here. I will like prove this like the tree I've made over here, like the recursive tree. I'll prove it in terms of stack, like f3, Fibonacci number of 3, it's going to call Fibonacci number of 2 and Fibonacci number of 1. Firstly, it's going to solve Fibonacci number of 2, which is equal to like Fibonacci number of 1 and Fibonacci number of 0. It's going to solve the left hand part first, f of 1. It will check against our base condition and it will return 1 to it. Like it will return back from where it was called. It was called from f of 2. Now it will like execute right hand side of right hand side of this problem. It will like f of 0, it will check it against our base condition, so it will return 0 from here. It will like add 1 and 0. It will like 1, return it from from where it was called. It's called from here, so 1. Okay, so then it will execute the right hand side. It will like f of 1, it will check it against our base condition, then it will return 1, then add 1 and 1, which is equal to 2. Let's see if it's happening. So it's going to check against our base condition. Initially n is equal to 3. It's going to check if n is equal to 0 or n is equal to 1. It's going to be like it's not. Okay, just ignore this block of code, ignore this return statement, and like move on to here. It's going to move on to here. Now it's going to like uh, check this return statement. It's this function is calling on itself, but the argument is like n minus 1. So it's firstly going to like calculate like this left half. Let's see, that's the case. Yes, n minus 1, which is equal to 2. It's firstly going to calculate this one. It's going to see, let's see where we are currently at. It's currently at here, at like this step, f of 2. It's once again going to check if n is equal to 0 or n is equal to 1. It's going to be like, no, it's not. Okay, just move on to this step. Once again, it will be like, now we are at like this step, f of 1 and f of 0. We are at like this step. Obviously, it's going to be like execute the left hand side first, and as that's the first function call. Now it's going to be like n is equal to 1, as 2 minus 1 equal to 1, n is equal to 1. Okay, so it's going to check if n is equal to 0, if n is equal to 1. N is obviously not equal to 0, so this is false, and n is equal to 1, this is true. So it will just return n, which is 1 in this case. Okay, so let's see where it will return this one. Here in the diagram, it is returning it back to 2. See, it's returning it back to 2. N is going to be 2. Okay, so return n. Okay, see, n is equal to 2. Like it's returning it back to from where it was called. Like this f of 1 is called from this f of 2. This f of 1 function call was made from this function call. So it is when it was executed successfully and the result was 1, it's going to return it back to here. Now it's going to like move on to this right hand side. Now f is equal to 0. Like n is equal to 0 now. Let's see. It's going to move on to the right hand side. N is equal to 0. It's just going to check if n is equal to 0 or n is equal to 1. It's going to be like n is equal to 0. Just return n. Return. It's going to like return it back to 2. See, n is equal to 2. It's going to return it back to from where it was called. Going back to 2. So, okay. So this 2 was resolved. F of 2 was resolved. Now it will go back to from where it was called. It was called from f of 3. So it will go back. N is equal to 3. That's fine. Now see, this left hand side has been resolved. Okay, the left hand side of this problem, this whole side has been resolved. In code terms, like this part has been resolved. Now it will like f of 3 will move on towards this. So f of 3 minus 2 is going to be equal to f of 1. N is equal to 3. Okay, let's see. N is equal to 1 now, as it's moving on towards this part. This part. Going to move on towards this part. Okay, so it's going to check is n equal to 1. It's going to like, yes it is. Just return 1. Okay, return 1 to where? From where it was called. N is going to be equal to 3. N is equal to 3. See, 1 was being returned from where it was called. It was called from f of 3. Okay, n is equal to 3 now. Now it's going to add 1 plus 1 equal to 2. Okay, so it's going back. Now see, this whole function is going back to from where it was called. It was called from here, stored in this int, and it will just then printed, and this is equal to 2. Print 2. I hope it was clear. Let's just do it with see, we have done binary search in the past, right? Let's just try like this recursive method in case of binary search. Let's see what happens. Like we had done that using iterative method only, like using a while loop. Let's see if we can like binary search using recursion. Let's see. So I'll just say public static void main, and here's going to be an array. Sorry, I've been coding in JavaScript for a while now. Int array. I'll just say it's going to be like 5, and our target element is, let's say our target is 2. Okay, and I'm just going to print, I'm going to print search array target. Okay, let it be like this for now. So I'll create a method search static. Return type is going to be int. See the return type, like I'll make it clear in a moment. Static int, let's just name it as search. So it's going to hold an array, and array is going in as argument, target as well. Okay, so like in the iterative method, what we used to do is there was like a base condition. If like start is greater than end, just return -1. It means like the element you are looking for is not like in this array. Okay, so this could be our one base condition, which will like stop this function from like calling on itself infinitely. The second condition we had was if array at mid is equal to target, just return mid. And what was our mid? Our mid was start plus n minus start whole divided by 2. This was our mid. Okay, so see why I'm like keeping this mid within the function body, and what about the start and end? What are, like in case of recursion, what is going to be the like return type? In this case it's int. I will tell you why I have like selected it to be int, and like what are going to be the arguments in case of recursion, and what's going to be the like data type, or what's going to be like in the body of function in case of recursion. See, in the arguments what I'm going to pass is in arguments I'm going to pass like those things which I want to pass on to the next function calls. I can't like explain it much more simply than that. These are the things which I want to pass on to the next function calls, and this thing, it's going to like it's only specific to a function call only. It's going to be calculated like dynamically for like every single function call. What we do in like binary searches, what we do is we like we like divide the search space in half every time like the loop runs, but here we are not using loops. So how can we like keep track of those pointers, like those start and end? We're going to use function calls for that, so we have to pass these as like parameters, as arguments. I hope it's clear. And mid, it's going to be like being calculated for every individual function call, so it's not like something specific. It's like specific for every function call, but these two are not specific. We are going to like change these two only, and according to that the mid is going to be like calculated. So I'll just say if array at mid is equal to target, just return mid, and the condition I might have is if target is actually less than array at mid, what we used to do in that case, like the target is not in the right half, so it's going to be in the left half. We used to do and is equal to mid minus 1. What I'm going to do here is I'm going to return whatever the answer is from search, and the array is going to be the same, target is going to be the same, start in this case is going to be the same, and is going to be equal to mid minus 1. See, I'm modifying these two things, start and end. Like if target is less than array at mid, I'm going to like modify my end. Like it's not going to be specific for any function call, it could be anything. So I'm passing it down using like parameters and arguments from one function call to the next. But for mid, it's going to be like calculated dynamically over here. Whatever the start and end is, it's the mid is going to be calculated according to that. I hope it's clear. And if that's not the case, if like all of these conditions don't check up, it means the target is greater than array at mid. It means the target element is not in our left half of the array. It means it's in our right half of the array. So we are just going to do start is equal to like mid plus 1. Search array is going to be the same. Target is going to be the same. Start is going to be equal to mid plus 1, and end is going to be equal to end. We are not going to change that. So I guess that's pretty much it. Start is going to be equal to 0, and end is going to be equal to array dot length minus 1. Okay. So our true is that like first index 0 at first. The answer should be 1. The answer is 1. Let's put like a debug pointer over here. Let's debug this. It's going to be like search, yeah, like got into this function. It's going to be like is start greater than end. It's going to be like no, it's not. Start is 0 and end is 4. Okay, then ignore this part and move on to here. M is equal to start plus end minus start whole divided by 2. Start is 0 and end is 4. It's going to be like 2. Mid is equal to 2. Array at mid is equal to target. Target is 2. M is equal to 2. It's going to be no, it's not. Array at 2 is not equal to target. Array at 2 equals 3, and we are looking for just 2. It's going to be like if target is less than array at mid, target is 2 and array at mid is 3. So it's going to like yes, you are right. This condition checks up. So it's just going to like return like use this function once again, but this time end is going to be like mid minus 1. End is going to be equal to 2. Sorry, 1. As our mid was 1. Okay. So it's once again going to be like no. So this time our mid is 0. It's going to be like no, it's not. Target is 2, mid is 0. No. Now it's going to look for this. S is 1, end is 1. Start and end are both same. Mid is also 1. It will check if array at 1 is equal to target, array at 1 is equal to 2, that's our target. It will just return 1. It will return it back from where it was called. It was called from here. One. So this was pretty much it about recursion. I hope the video wasn't that complicated. It is a complicated topic, but it eases up once you practice. So yeah, that's pretty much it. Take care.